That last video cut out. Sorry about that. So what they want is how likely is it that you reject this potato, this truckload of 250? Well, we know that it has to be 10% or more, so that is 0.10. But we also know that our standard deviation of this from the part above is 0.0137. So that means 10% is very far away from the standard deviation. Because if you remember, in between -1 standard deviation and +1 standard deviation, this is 68% of the data. And if you even go even further from -2 standard deviations to +2 standard deviations, this is going to be 95% of the data. Well, this 0.0137 is more than 3 standard deviations. In fact, it's closer to about 6 or 7. So if -3 standard deviations all the way to +3 standard deviations is 99.7% of the data, and this 10%, that's very far away from the from the mean and the standard deviation. Therefore, it's very unlikely the truck gets rejected. Next one talks about a phone company interested in exploring possibility for a new smartphone for teenagers. They're going to ask a simple random sample of 10,000 high school students whether they own a smartphone, and say 65% of students do. What is the probability that a random sample selected by the company will result within an estimated p proportion value within 3 points of the true population proportion? Try to show that this is a normal curve. Well, I know my number is 1,000 and our proportion is 0.65, and this ends up being 650 greater than 10. So this will get a nice old check mark. And then n1 minus p is greater than 10. And if you guys haven't figured out, these two numbers always combine to the total sample size. So sure enough, that checks out. Since it's normal, let's find our standard deviation. And our standard deviation, because we already know our estimated mean is p, which is 0.65. The standard deviation is going to be the square root p, 1 minus p, all over n. And if you were to calculate that, that gives you 0.015. Now I'm going to draw my pretty picture. And what we want is we want within 3 percentage points. So that means I'm looking all the way down to 62%, and all the way up to 68%. And what you guys could do is actually go ahead and calculate the z-score for that. But if you want to be clever and a little faster at doing this, you could say, well, hey, my standard deviation is 0.015. I know that this is the first standard deviation mark, at 0.665, and down here it is at 0.635, and the second, so this is -1 standard deviation, this is 1 standard deviation, so that means that this 0.62 is actually -2 standard deviations, and this is +2 standard deviations. And we had a rule, the 68, 95, 99.7 rule, and here we go. 2 standard deviations is right here. So that means that approximately 95% is, we have a 95% chance of being within our true population mean. And I guess I should clarify a little better. It's saying our, when I say our P, or estimated P proportion, has a 95% chance of being within 3% of our true proportion mean. And once again, if you didn't recognize that 0.62 and 0.68 were 2 standard deviations away, just calculate your z-score. You would have got the same answer.